4.6 number 2 is dealing with a cotangent graph. And so let's start out. When they say the amplitude, we don't really have amplitude for cotangent and tangent. It's more of what we talked about in the lecture. It kind of is the steepness. Remember, you could have just a nice smooth S, or maybe it would be really skinny. That's never a little skinnier, so it's being vertically stretched. And in this case, the steepness is going to increase by 2. Not that we'd really see it on the graph, so we don't have to worry too much about it. There's nothing being added or subtracted outside at the beginning or end, so the midline or the middle of the S would be at 0. And in this problem, the b value is pi, and so the period is always pi over b, so we have pi over pi, which would be 1. So in this case, the period is 1. And then remember, you do period divided by 2, and so this is 1 over 2 for the period of this function. And the phase shift, there is no phase shift because nothing is being added or subtracted inside the parentheses. So that means my very first critical point will be at 0, and then we're going to just add a half. So half, and then 1, and then 1.5, and 2. And you could go backwards. So you could go back to -1/2, -1, and so on. But these are the 5 that I would concentrate on graphing. Now, with cotangent, we have to remember that it is going to start with an asymptote, then a 0, then an asymptote, then a 0, and it just keeps alternating. And cotangents go up to the left. So any graph right now that's going up and to the right, we could get rid of it because those would be more like tangent. So now let's concentrate on at 0, I should have an asymptote. And on this graph, at 0, it's crossing the x-axis, so I don't want that one. But at 0, I can see this is an asymptote. And then remember, 1/2 is a 0, good. And then 1/2 is an asymptote again. And so that's why we would choose this graph.